a small vlog about the things that I'm working on. I'm working on a 433 megahertz receiver. That's here. And I wanted to supply it via a mains supply and a tiny transformer. That's here. And in the video of, say, yesterday or a few days ago, I have talked about the problems that such a mini transformer can give. But finally I made it in a good way. Bridge rectifier here, capacitor of say 1500 picofarad, sorry, microfarad, not picofarad, 1500 microfarad at say 25 volts. And here we lead out the positive lead and the negative lead to this beautiful chip that can receive radio signals on 355 433 megahertz. And I had to tune in, that's also important to tell, this receiver to the transmitter, and I've done that here with the help of a different lengths of the antenna. I tested it with a say 10 centimeter antenna and then with a say 30 centimeter antenna, and that proved to work better. And I could tune in here to the good frequency of the transmitter. That was the doorbell transmitter that I have showed earlier. Important to tell perhaps, when I did not mount here this very big capacitor parallel to the receiver unit, it's 1000 microfarad. The whole unit started to oscillate. That has of course everything to do with the wiring here, the fact that the receiver circuit is supplied out of the main supply, that is 230 volts, and then rectified. So here we have all kinds of say influences, especially capacitive influences, because we send in via this wire that has a certain length, that has a certain frequency in general, by the way. But anyway, there is a stray capacitance in this lead going to that receiver chip. So I try to mimic the original situation where such a chip is supplied directly, say in this way, out of a 9-volt battery. So that means that there is a very fixed, say, capacitance and inductance regarding the wire lengths, and of course such a battery also has properties in terms of capacitance, stray capacitance, in terms of resistance, stray resistance anyway. But the whole chip, the receiver chip, was made for this 9-volt battery. So the whole setup is, say, pointed to that situation, and now it differs a lot because there is a long wire here going to a main supply, etc, etc. But anyway, I could damp out all these, say, strange effects, oscillations, etc. by mounting here between the positive and the negative a 1000 microfarad capacitor. And also important to tell, there is here a series resistor, there's another one here. Together they are approximately 2000 ohms. So out of this mini transformer there is a resistor of say 2000 ohms. It goes to that 1000 microfarad capacitor that bridges the receiver, and then it all works fine. And the length of the antenna was also very important. I tested it and tuned this circuit to the right frequency. Anyway, I tried to calculate something, and that was the next problem. This is my calculator that I have used always many times, and it works on this battery. I don't know what type of battery it is, but it worked for say 3 or 4 years, and even up until now it has approximately 1.5 volts. That's very interesting, and that also shows that this very cheap, say Chinese calculator, works very properly with this chip inside, the calculator chip. So that's revealing in a certain way. It's very cheap, and you see the calculator. It has no say manufacturer brand or whatever. You see them everywhere in shops. Anyway, this battery didn't work very good because we had, and you can see it perhaps, some oxidation inside. And the oxide here, that was a green oxide. I am more or less sure that that oxide, metal oxide of course, because this is metal, conducted between the positive and the negative, and had say a slight deteriorating effect on the voltage. Anyway, I scraped off all the oxide here, and I will put in this mini battery again. Beautiful battery, by the way. So I put it in again, and I have already seen, I cannot show that because otherwise the whole calculator falls apart, that it works. So that's good. And to say keep this calculator for a very long time, I've soldered here 2 wires, a positive and a negative. And I'm going to use some good quality kit here to fix that wire, and also here to fix that wire. And on the longer term, when I cannot get this mini battery cell, I can use a 1.5 normal battery, and I'm sure it will work properly. Not for 3 years, but perhaps for 10 years or so, till the whole battery depletes, gets very corroded, etc. But anyway, it's a kind of way to say use such a calculator for a very long time. Perhaps it costed €2 or $2, but well, let's give this calculator more time to work properly, because of course we have here inside a beautiful calculator chip. it is not worse to throw that in the garbage when some contacts get corroded or the battery depletes or whatever. Anyway, that was all.